Hi, everyone. Today we're going to be talking about mobile web performance. The slide deck is up at my GitHub. Just remember my name, Estelle, and there's actually an index page with all the talks listed there. So the idea is you don't want to break the web. And I basically broke my slide deck 15 minutes before going up, and it's kind of intentional. So you can break my slide deck, but don't break the mobile web. So the point of the things you want to focus on when you are developing for the mobile web is you want your site to be fast. You want it to be fast to load, fast to render, fast to respond, fast to understand. You also want it to be beautiful, understandable, and eco-friendly. So the beautiful, that's the developer, that's the designer, but everything else is your responsibility. So in this talk, we're going to be talking about the current mobile ecosystem, some performance concerns, and then some issues and solutions on how to address those. So the mobile ecosystem. In 2016, these were the top phones that were sold. They range from 172 to 670. They range from 1 gig of RAM up. And they've got decent ROM. And some even have dual-core 1.8 gigahertz dual-core processors. In terms of the world, about, we live in a country, whether you're here in the UK, from anywhere in Europe, or in the United States, anyone outside of Europe or the US here? Where are you from? Canada. I should say North America, but you're kind of like a suburb of New York. I'm kidding. So yeah, I'm American-centric like all other Americans, and I'm sticking my foot further down my throat, so I'll stop. So if you think about the web, there's over 1 billion people that are not yet online in India alone. So I like to think about Indonesia, because Indonesia has almost the same population as the United States. It has internet access. Indonesia is down there, and you'll see it's completely green, right here. You can get internet access, Wi-Fi, no matter where you are. And yet, the same number of people are online in Indonesia that are offline in the United States, and the same number of people that are offline or online in the United States are offline in Indonesia, pretty much. So let's talk about their phones. This is what they're using in 2016. So the top phones are affordable feature phones that cost $27 that have 32 megabytes of RAM. There are some smartphones, including the Infinix Hot 2 X50 and the Tecno P5, which has a dual 1.0 dual core. So 2 gigahertz total. What you need to realize is while you have this limited RAM of 32 to 1.2 gigs, when you are running something on your phone, you are running your operating system. So the browser only has what's left. And this was my phone when I had 3/4 of a gig. So it's not my newest phone. And my newest phone is really old, so it doesn't really matter. But the day I bought my phone, this was what was running on my phone. I had either 73 megs of RAM available or 182. I didn't really know how to read it. But basically, I was sold something with 3/4 of a gig, and I had less than 1/4 of a gig. Mobile phones or mobile devices are kind of like computers. I mean, they have increasing CPUs, increasing prevalence of MSC, improved RAM. We're getting there. But what's happening is, as developers, we're developing on the equivalent of what is an airplane. When in Indonesia, the most common phone is the equivalent of a paper airplane. I'm not saying you should be developing your site for the paper airplane, but do develop your site for a drone that has a limited battery and a camera. Because battery is a major issue. The average cell phone has a battery that is less powerful than that battery, the little battery right there. So we have dual core processors, right? but we have that crappy battery. So let's just take a look at the iPhone. The iPhone has a battery that is 1,715 milliamp hours. This battery right here is 2,000. So that is a crappy battery. Like the Duracell was actually a better battery, at least according to advertisements that I've seen on television in the United States. I don't actually know all the specs of both. But you're running something with a really powerful processor with a battery that cannot handle that processor. So you're being sold these processors, but no one can actually use that speed. So the battery is really the limiting device on a mobile device. So you really have to think about it. So when you are thinking about different devices, realize that the watch, the fridge, the TV is not a laptop. Some of those are plugged in, like the browser on your fridge, but some, like the one on your watch and the one in your pocket, they don't. Their battery is quickly draining. There's latency issues, there's memory issues, and you also have to think about responsiveness. The browser is basically equivalent to the desktop. I mean, you have all the capabilities, but you have a device that isn't. You have less powerful CPUs, because even though you might have a dual core, the battery is, like, you've warmed up your phone. It's not even at full force when your phone's warmed up. It's not plugged in. People have metered data, tiny screens, and different interactions. Okay, so let's talk a little bit about mobile performance concerns. Don wrote, just because no one uses your mobile site doesn't mean that you don't need to improve it. That it doesn't mean you don't need to work on it. Maybe no one is going to your mobile site because it's a shitty experience. She was more polite than I was and did not swear. And then Stephen wrote, I remember when 3G was the primary mobile speed. Stephen's in the United States, in California. It was slow, but it still worked. So why now when my phone says 3G, and this was a year ago, it becomes completely useless? Well, maybe this is the reason why. When we started off with 2G, or even 3G, the average website was 0.7 megs, 702 kilobytes. As of the beginning of this month, we are at 3.3 megabytes. That's a difference of 479%. That's 7 years. So let me tell you a little story, and this is a really old story. It's from 2012. In 2012, the average website was probably 1 meg, or 1.2. YouTube had 58 requests and 1.2 megs. So someone on the team did a study, or on his 20% time, did a thing called Feathers. And it was a mobile YouTube site, and it had 14 requests. He basically gave himself a budget and said, I want to be under 100K. And he went under 100K. He wanted to do 12 requests, but he was at 14, and that's good enough. So he launched this site at 100K, and then 2 weeks later, he looked at his stats, and the average download speed increased by 2 minutes. So you're thinking that's 1/6 or 1/12 of the size, and it increased by 2 minutes. What happened? Well, people were accessing his mobile, rather, it wasn't mobile, it was just regular, and it was also worked on mobile. People in Siberia and Africa were finally able to get YouTube videos. And so they were willing to wait the 2 minutes. A friend of mine had a problem with the site, and he asked the person, someone contacted him from India saying, I have this issue with your site. And he said, oh, by the way, tell me, how fast does it take to load? And he goes, oh, it's under 30 seconds. It's really good. So we have a different perspective. But you're opening up new markets if you're the fastest in that market. So you want your page load time to be 1 second or less. But if your competitor is 4 minutes and you're 18 seconds, in Siberia, you're doing well. Okay. So in terms of web performance, you have to think about the number of resources you're downloading. That includes all the images, JavaScript, blah, 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 which is now at 3.3 megs on average. All that information needs to be parsed and executed and painted to the screen. But even though if you're measuring all your metrics, you still have to think about what is perceived performance. What are your users perceiving as? The metrics don't really tell you everything. You want to make your websites fast. So let's look at some of the issues and solutions. What we've talked about so far is basically some of the knowns that we have. You are in control. As developers, we control the number of HTTP requests that we put out. We control the number of bytes. We control whether we have animations and whether those animations can be painted to the page, whether all the JavaScript can be run and the animation can be painted to the page in less than 16.67 milliseconds. We also can control the squishiness of the website and the responsiveness. Squishiness and responsiveness are two different things. People call something called responsive web design, which to me is whether your site is squishy, right? If you use a media query, it makes your site squishy. It does not make it responsive. Responsive is whether it downloads quickly and whether it reacts when you touch it. So I think of those as two completely different things. What we don't have control over is the network that our users are accessing our site, what hardware they're using, and what browser they're on. So all your downloads basically go through the same process. If the user makes the HTTP request, you have to do a DNS lookup. And we know what's going on. You want to make these as fast as possible. We know that style sheets are blocking. We know that scripts are blocking. But we also have to think about every DNS lookup that we do, especially in the mobile space. Because when you are on desktop, when you're tethered, or when you're on this Wi-Fi, your computer or your laptop that's on the Wi-Fi says, hey, I want to go to this site, google.com. It goes to a DNS server, says, what is that IP address? Sends it back really quick. When you're going to a cell tower, it's basically saying, let me see if I can make these bigger. There we go. You're going from your phone to the cell tower to the phone company, which then does a DNS lookup, which sends the IP address back to the phone company, back to the cell tower, and back to your device. And then you can finally make the request. So it takes much longer when you're on G2 or 3 or Edge or whatever. And where the 1 and 2 is, that is actually where the largest latency is. So there's some things that we can do to help with latency or to hurt latency. But sometimes hurting latency is a good idea. So having a CDN, meaning that you have your assets all over the world closest to the user, is a really good idea. If you're like Opera Mobile and you have a proxy server, there you want your CDN to be closest to to the servers because you're just sending one request. But generally, you want a CDN, you want it located all around the world. Something that slows down websites, but it's totally worth it, is having a secure site. You do want to put serve your site over SSL. The TLS handshakes takes 2 to 3 times as long, but it's totally that's where that's okay to add weight. If you are, what you need to realize is that the network is basically only going to be as fast as your slowest packet. So if you're developing, especially native apps, this is just for future thinking. BBR congestion control allows it to be faster than your, and this is, Google Cloud has implemented BBR congestion control. Not fully relevant to the talk, but there is a link to that in case you want to read up on it. And dynamic packet recovery is similar to BBR congestion control. So that basically says unblocks bottlenecks and recovers drop packets. So if you're doing that, look into those things. But let me get back on topic. So in 2015, Google came out with Rail, which is a misnomer. It's actually liar. And for 2 reasons. One, because you're never going to actually get a page load of 1 second. But if you look at the colors, they're in order of load, idle, animation, and response. So those recommendations had 4 things, but I'm going to talk about 2, which is the page load of under a second and the idle of under 50 seconds. An idle of under 50 seconds, you know what a page load of under a second means, but an idle of under 50 seconds means whenever you're running the script, do it in chunks of 50 milliseconds or less, because if you're using up the main UI thread for more than 50 milliseconds, your site is not going to be responsive. People are going to touch things; it's not going to react. These are some and this is the navigation timing API metrics, and I basically just put them in for the colors. So, because DNS, DOM content loaded and onload are things that we look at a lot. And you want to minimize all those, right? You want to minimize all of these times. So here is a site, and this is the 37-second mark where the pink ends. So it loads in 6 seconds. The document complete is at 29 seconds. And the UI thread is finished at, is available at 36 seconds. That's a so when you're actually measuring things, don't just measure page load time, because that looks good, right? So basically, I've told you what we have control over, and what you should actually realize is that we do have a little bit of control over the network latency and bandwidth. Those are things that we can actually have an impact on by reducing the number of DNS, by having a CDN. So I created this website, and I'll just let you read it for a second, because I think it's really funny. It was my April Fool's joke. So I decided to try to make this fast. And the reason I pointed out that the last one was all the way to 60 seconds is because this ends at 1.2 seconds. So you can load a page in under a second. And this is actually Google Analytics. So I just removed Google Analytics, and now we're at 0.8 seconds right there. So why am I showing you this? Because I used some tools to help me figure out where I could improve. So there's several tools, and there's several rules. There's YSlow, which came out many, many years ago. And it gave us 14 rules and gave you a grade of A through F. And what was I going to say? And so I used it for like 3-4 months, and then I memorized all the rules, and I never checked my grades again. But that actually helped me do well in performance. PageSpeed has had more rules. Web Page Test is a great place. I'll add links to all of these. I'll highlight, put those in blue. I'll update them so when you go back to this deck, you actually have all the information. There's developer tools, which those were screenshots. Actually, those were screenshots of Web Page Test, webpagetest.org. There's developer tools, which has flame charts. All of these things can help you. And then there's a new tool called Lighthouse, which I'll cover in a second. But these are some of the rules that they come up with. I disagree with one of them, which is use AMP. But generally, they're all good rules. So let's talk about Lighthouse. Lighthouse, which at this point is in your Chrome developer tools, but it is also headless. You can do headless. You can do it with an npm install. All the information is up there. It tests 4 things. It gives you information on 4 things. It gives you information about how far along you are in developing a progressive web app with a web app with a PWA checklist. It checks your performance, it checks your accessibility, and it checks your best practices. So this is what my site looked like when I first, that machine learning workshop for computers who want to learn good and do other stuff good too. It was definitely not a progressive web app. I had some performance issues. Because I always develop with accessibility in mind, I did pretty well. But I had some best practices issues. So basically, the reason I'm pointing this out is because it told me what my problems were, and it helped me build a better site. So use this as a learning tool. It's called Lighthouse. So the way Lighthouse works, oops. I'm going to open up a different window. So what you do for Lighthouse is you open up a website, you go into your audits panel, and you click Perform an Audit, and it gives you 4 choices. I leave them all. Definitely check accessibility, not just performance, because if your site isn't accessible, it doesn't matter how fast it downloads if they can't use it once it's downloaded, right? And you run the audit. It checks to see how it works in mobile. It limits the bandwidth. It checks to see if the size is the same size as your viewport, et cetera. And then it gives you a result. So I sped up and got the result already. The cool thing is, if I can get to it, apparently not, is this little button right there, which allows you to download it and save it. So once you've downloaded it, is this my talk? Yes, it is. I can just click here, open up my final score, and review it. So when you are using Lighthouse, grab a screenshot or grab one when you first start so you can feel better about yourself at the end. Because I got up to 64%. Why didn't I get up to 100%? Because it's a single-page, static website, and there's no reason to add JavaScript so that I have a framework or so that I have service workers for push notifications or anything else to have it work offline. I could, but then it would load slower the first time, and I don't think anyone's going to go to my site twice, except for me, because I like it and I think it's funny. Okay, so solutions. Step number 1 to make your mobile website performant is to not be a jerk. And you are a jerk if you tell your users that they can't zoom in or zoom out on your website. And if you don't serve your website the same width as the device. So there's a viewport meta tag. So it's meta named viewport. And you want to set content width equals device width. And that will make your width the right size. So all I did was add that one line to this Alexa homepage. And it went from that, which is a useless website, to that. It didn't change the download speed at all. But that performs better when it has, performance is all about user experience. That's better user experience. Gmail doesn't let you zoom, right? That is being a jerk. If you are doing a game and the person's going to flick the screen a bunch of times, that's okay to not allow zooming, right? Because zooming would actually make the game not work. Any other scenario, initial scale of 1 is fine, but maximum scale and minimum scale and user scalable no are no-nos. Luckily, it doesn't default. It defaults to initial scale 1, user scalable yes. But you do need to put width equals device width, and you do need to include the meta tag, or it'll look like that other site. Step number 2 is actually hitting the lowest hanging fruit. When we looked at that 3.3 megs, 1.814 megs, I think, were images. So optimizing your images is the lowest hanging fruit. You want a gzip. Doesn't help with binary, but does help with SVG. Well, I'll go through all of these. You want to remove image data. Don't send extra data that no one needs, and not only that, but it's a privacy issue. They don't really need to know where you took the picture and on what day and where you live. Resize images. Serve the smallest image file for the screen size and resolution. And let me explain something here. So these are basically the breakpoint when you are serving images. The smaller the bigger the image, the more breakpoints you want. Because if you have a smaller image and it's not the right size, so you're serving an image that is 240 by 240, but you really need 200 by 200, you're wasting 17,000 bytes. That sounds like a lot, but nothing compared to the 65,000 once you get to a bigger size. Those are all just 40 pixels by 40 pixels waste, right? The larger the image, the more pixels that is. So when you do breakpoints, realize that that's happening. Okay. Also, you want to serve the right size image because when you have to resize an image, it takes a lot more CPU and a lot more time. So it takes 3 times as long to decode the image. Now, this is a little bit old. I haven't tested this recently. I'm not 100% sure if it still takes this long. But it probably still takes twice as long because they have to decode it twice. The blue is the decoding, the green is the frame per second, and the purple is rendering. But one thing to notice is that scale, this bottom scale is from 0 to 100, and the top scale is from 0 to 200. So it's actually just make the top one twice as big. This was from Physics of Fast, which unfortunately is no longer online. It was put together by the performance team at Internet Explorer. Use picture, source, and source set. You can serve multiple images, and they'll just pick the right one. So if you're doing background images, you don't need, you can use media queries and serve the right image. And if you're doing foreground images, there's the source element, and there's also the source set attribute, which you can put directly onto the image element. So use these. I'll add a link for a good article on this. Optimize all your images. Compression, that's the easiest way to get savings. It's easier than serving the right size image, blah, blah, blah. It's less work, basically. There are some tools right there, and some of those can be automated. Use the right image format. So some images look better as SVGs, some looks better as GIFs, some looks better as PNGs. But you don't want to serve a PNG because they're all the time because they're huge. So serve WebP if you can. Serve JPEG if you can. One thing to note is if your browser, these are the fastest images per browser, but if you're, there's services that will automatically send the right image format without rewriting the code. So you can actually send a WebP with a .jpeg extension. If the browser understands the media type, it will decipher it. Even it doesn't matter if it says .foo at the end. If it knows it's if it's encoded correctly, it will work. So that's kind of a trick. Reduce the number of images. Generally just reduce the number of images. But also you can use sprites, or if you're going to have to use lots of them, use HTTP2. There are some CSS effects, like instead of using images, use gradients. Don't use too much complex gradients if you're going to animate them because the battery issue on devices. There's also something called masking. So when you have a JPEG or a PNG that has transparency, and it's a huge file, but you need the transparency, so you could serve it as a PNG or as WebP with transparency. But not all browsers understand WebP, so you want to send a PNG, but that's huge. You can use CSS masking. And so here, what this is it's a JPEG of a phone instead of a PNG of a phone. And then I have a mask that says, just show this outer amount. And that is the code for it. And basically, by using a mask, you can say, I want this part to be opaque and this part to be transparent. And the PNG plus the JPEG, like this small transparent PNG or transparent GIF, is like 1/10 of the size of the had I served the transparent JPEG as a transparent PNG instead. So that was actually 55 kilobytes, and it's now 8. Okay, because that's a tiny little image. But there was one time I did it, and I basically broke the iPhone 4 because the image was too big. It just wasn't enough memory. It would crash. And then I switched it to that and saved half a meg. So the tip number 3 is optimizing video. So step 1 is just don't send a video. So how do you omit the video? You basically say, don't show the video unless it's a big screen. Or you can also use navigator.connection, or the connection API. And that's blue because it's a link to the spec. So you can basically say effective type. Did I open this up? Let me just open this up in a different window. Let's not wait for it. OK, so there is, so there's basically, you can say, is it, well, let's see if it opened. No, OK. You can basically say, is it cable? If it's cable, then send an image. This is one of those things with great power comes great responsibility. Just because you can use it, don't use it to do things that it's not meant for. So don't serve the video if they're on a lousy connection, or if they're in a country that tends to have that has to pay for the bytes. Then when you serve the video, use the source attributes, right? I mean, the source element. You're going to put the various videos, put them in order from smallest to largest, because the smallest one that it will understand will be the only one that it downloads. So if actually changing just the source order of your sources can save bytes. Then the third step, or another important thing is, if you have a hero video, it's muted, right? Those things that are animating behind your header. Why are you sending the audio, right? So if it says autoplay and muted equals true, remove the audio from the file before you download it. FFmpeg, which there's a link right there in blue, you just basically, you can automate this, remove all the video. I think you should just remove the video, but. And rule number 4 for improved performance is everything else. Those were the lowest hanging fruit. The number 1 was not actually a performance, but the 3 others, the 2 others were reducing your images and reducing your videos. Putting the style sheet at the top, putting the script at the bottom. Style sheets are blocking, but you can also just put the 1400, what you need for first load at the top. What's it called? Lighthouse really helped me with this because I realized it helped me save so much in terms of my CSS. In terms of the JavaScript, shrink it down to what you need. Don't send the 27 frameworks and 43 dependencies. JavaScript is what is using up your battery. I mean, it's actually the radio being turned on and the light, but then the JavaScript. Parsing and executing JavaScript down kills it. So let your code sleep. Like, don't keep getting AJAX requests every half second because you're just waking up the radio, breaking up the radio, waking up the radio, and minimize the amount of JavaScript. Basically, save that battery. Don't do things like this where you have 20 seconds of inability to use, well, it's not 20 seconds because there's little cuts in there. But you do have a 10 seconds chunk where the site is not usable. Don't do what I call resume-driven development. That big pink thing right there is a 2-second DOM content loaded event on a form with 2 elements, two input, right? Because there's 43 dependencies. So all of that JavaScript has to be downloaded, parsed, and executed, which is an 8-second download for that JavaScript file plus a 3-second parse and execution of that JavaScript file. Minimize the number of DOM nodes. That's another trick, and it's good to do anyway. Whenever you're, the more DOM nodes you have, basically each DOM node has to be resized every time there's a repaint, or reflow, rather. I already said there's a difference between squishiness and responsiveness. Disney went squishy. It did not go responsive. Their wide desktop site is 73 requests. Their mobile is 123. Their assets are pretty much the same, and the load time over a mobile network is incredibly slow. That's going squishy. That's not responsive. And the last thing I want to touch up on is HTTPS and some of the other features. Do add HTTPS. Make sure your site is secure, because all of the new features, like service workers and PWAs and AMP, which you shouldn't use, require HTTPS. So progressive web apps, basically an offline experience. Definitely recommend doing this. Lighthouse will help you figure out the steps to go through. Progressive web apps, I decided to make an illegible slide. These are all the benefits, which you can't read. And this is the reason why I'm so opposed to progressive web apps. We blame Facebook for the idiot that is in office in the United States. But this is my search result 3 days ago for the term Obama on my mobile device. 3 days ago. Jimmy Carter lets loose, knocks Obama and Hillary, says Russians didn't alter election, praises Trump. The Blaze. The Blaze is not known as a news source. But the top news sources it gave me was Fox News and Breitbart. Why did I get these search results? Because this is the AMP carousel. So the only people who should be using AMP is real news sources to kick the fake news sources off of the website. But AMP was basically created by Twitter and Google as an equivalent to instant articles on Facebook. And we're all blaming instant articles, but AMP is just as responsible to this day. So that is my little soapbox that I did not intend to go on. I'm sorry for that. So always build with accessibility in mind. Always build with mobile in mind. When you're testing on mobile, don't just use your testing device, right? Your high-end phone that you only use in your office. Put every single application that your teenage friend uses, because they have way more apps than your parents use, probably, or that I use. These are all my apps, basically, open. I couldn't make that much of a screen. Because there are other things using up the memory. And set a budget before you start. Decide how fast your how many bytes you're willing to go with, and how many HTTP requests. Scale down, not up. Don't prefix fallback properties. Like you don't have. There's very few prefixes, but don't add the prefix for border radius, or for animations, or for transforms, or the web-WebKit. Because if you're just trying to target Android 2.4 or something like that, it's basically going to slow down that device, and they don't need your rounded corners in the first place. Don't disable zoom, I said that, unless it's a game. Follow everything that we've talked about today, always keeping mobile in mind, because your users may not be tethered. Their memory may be limited. Their bandwidth, they might be paying for every single byte that comes through, and their internet may be unreliable. So remember that, and thank you. That's all I have to say. So just, can you put it back up just for a second? Slides are right there at the bottom. That's where you can find all my slides. And then there's speed perception is a study on speed perception, machine learning workshop. If you think my site is funny, share it. And then the conference is Performance Conf. And that's, thank you.
Thank you very much, Estelle.